Hi, thanks for joining this session, Above, Below and Beyond, Mapping Your World. Here, we're going to introduce the Pegasus 2 mobile mapping system, along with the Stream Up GPR. My name's Shane Gwilt, and I'm a product sales specialist for Leica Geosystems. I've been with Leica about 3 years now, introducing detection and survey equipment to customers across the country. I've about 30 years experience in the survey industry, working as a land and underground utility surveyor prior to joining Leica across a wide variety of sites and environments. I understand exactly what we need to do to get deliverables to the client on time, on cost, and also undertaken safely. I want to ensure that the sensors, the survey sensors and equipment that you buy are utilised fully across all the survey tasks you have to do, maximising their productivity. An example of this would be something like the GS18I working with a GPR. So we can utilise the tilt compensation and the IMU to ensure that we've got good positional information in the GPR. When we finish utilising the GPR, we can then remove that GS18I sensor and use the imaging function to ensure that we're picking up all the paint marks of a utility survey, for example, or there's a manhole that's in the middle of a dual carriageway or behind a fence that we can't get to safely. We can collect all this data utilising the GS18I that we've already used with GPR. It can be used as a QA of the site to ensure we don't miss anything, that we don't need to go back to site for missing information. I'm going to introduce Antonio Mendez, who's going to talk about the Pegasus 2 Ultimate, and then I'll come back and talk about the Stream Up. And then together, we'll look at the potential of these two sensors working together to create an autonomous solution.
Thank you, Shane. My name is Antonio Mendes. I'm a geomatic engineer working in the geospatial industry the last 20 years. I'm working close with mobile mapping since 2011, and I joined Leica in 2015. Since then, I'm helping promoting the mobile mapping business in all UK, Ireland, and Benelux. Starting with the presentation, I need to start with a simple question. What is mobile mapping? When we talk about mobile mapping, we are talking about sensor fusion. Mobile mapping is about the synchronization of multi-sensors as the GNSS able to track all constellations, IMU able to update our position every 200 seconds, and a point cloud LiDAR, for example, as you can see here in this video. We can, using the JetStream Viewer, for example, one of our latest Geosystems softwares, visualize all the point cloud and image all together and do quick measurements. In mobile mapping, and talking about mobile mapping, let me introduce our end-level solution, our Pegasus 2 Ultimate, where talking just in a couple of seconds about this product, I need to mention the accuracy. So we are able to achieve 1.5 centimeters level of accuracy in open sky environment with no need of ground control points. This equipment is able to track all available constellations, so talking about GPS, GLONASS, BeiDou, and Galileo, combining all that with a 360-degree image that will allow to colorize the point cloud and to navigate through the point cloud as well. And in addition, we've got 4 side cameras, high resolution side cameras, and a laser scan able to capture more than 1 million points per second. The IMU, Inertial Measurement Unit, is an additional sensor able to update our position 200 times per second. There are a possibility to include external extra sensors as pavement cameras, thermal cameras, and as at the end of the presentation, you will see the possibility to do the integration with our ground penetration radar. Let me explain now how does Pegasus work? So as all systems that rely on GNSS and post-processed data, we need to start with 5 minutes of static and 10 a few minutes of dynamic. And after that, after good initialization, we are able to capture all data. So capturing data with a Pegasus vehicle mount solution means that I can drive traffic speed with no need of traffic management, with no need of road closures, and I will be capturing 1 million points per second up to and 8 images per second if necessary. If we realize that this amount of data is not enough, we can drive always more than once, with the advantage that we will be able to rotate the LiDAR and will give always a different resolution. And you can see here now a new profile is 30 degrees left and in addition 30 degrees right. In our mobile mapping solutions, I need to mention as well our Pegasus backpack. So exactly the same sensors as the vehicle mount solutions, and in addition, we've got SLAM technology, and SLAM means simultaneous localization and mapping that allows to capture not just outdoor but also indoor and underground. This is a lighter solution, it's just a 13 kilos system, and the IMU inside of the Pegasus, in the Pegasus backpack configuration, is IMU that will update our position 125 times per second. Moving forward in the presentation, I would like to basically just tell that we can work with a Pegasus backpack, with a Pegasus 2, almost everywhere with no limitations. You can see here lots of applications on highways, on rail, or off-road, or something that we will explore at the end of the presentation, integrated with the ground penetration radar, for example. I would like to share with you 2 or 3 different examples. So the first example that I will share is one application of the Pegasus backpack in the airport. And it seems that it will be a not challenging environment, but the challenge in this kind of projects is the level of accuracy that is required. In this particular project, it was required the 5 millimeters level of accuracy in Z, and for that, our customers were working with lots of control points. In that case, 95 ground control points, and in our software, we are able to detect automatically that points and then adjust the point cloud. The final results were quite impressive, and you will see here that we had, that points a single outlier with 6 millimeters out of spec, but the standard deviation of the project was 2 millimeters. Other example is this one, and here you will see how efficient can the Pegasus 2 be in a project like this one, and this is the interchange from the M25 with the M3. And probably before I tell how much time took me to capture this data set, I would like to ask, how much time do you think that this will take to capture using traditional methods? I made that question in different forums, in social media. I asked customers, and they told me that this will take at least 30 working days to capture this amount of data. 30 working days means 30 days of traffic management, 30 days of lane closures, 30 days of a survey team on site. I will not talk about the cost of all that. What I will say is that all these took me 3 hours to capture and 1 additional day to process. In addition, we work with a pavement camera that was able to create orthophotos for all road, and with our software we were able to do a pavement analysis and do a crack detection as well. One more time, all these took me 3 hours to capture and the second day to process. Something else that is important in a mobile mapping presentation, and probably this is my important slide in this presentation, is try to explain the advantage to work with mobile mapping. This slide is the result of a survey that we did at the end of 2018, and we asked to more than 100 users of mobile mapping technology around the world what are the advantages to work with mobile mapping and what can take what change in their workflow since they adopt mobile mapping. And let's just take a look for the same level of accuracy. So for a traditional 10 mil level of accuracy, what our customers are saying is that in mobile mapping, they can be 4 times cheaper, they can deliver the data 2.6 times faster, and probably the most important is the time that the surveyors are now on field are almost 6 times less. So faster, cheaper, and safer. Something else that I would like to mention in this short presentation is the advantage to work with a Pegasus software. We are now with machine learning and artificial intelligence algorithms that allows, as you can see in this example, to classify in automatic way all captured point cloud in different layers, such as road, pavement, buildings, low, medium, high vegetation, or as you can see now, moving objects, all that are in different layers. Working with artificial intelligence, we are able also to respect GDPR, and all image can be blurred, so the face of the people and the registrations of the vehicles can be blurred, respecting the demand of GDPR. On my last slide, I'd like to ask you, what can you do with the data? Please bear in mind, with the Pegasus mobile mapping solutions, we are able to capture 1 million points per second. We are able to capture image every alpha meter if you need. We can work with or without ground control points. Saying that the solutions are endless. So the best way to answer this question is try to understand your needs, and together we will find the right workflow to achieve your needs. It's now time to hand over this session to Shane, and he will continue the presentation talking about our StreamUp. Thank you.
Thanks, Antonio. Okay, so let's have a look at the StreamUp GPR along with the post-processing software IQ Maps. The Stream family of radars are made up from 3 different units. We have the StreamUp, which stands for utility patrolling, the StreamC, the compact array, and the StreamX, which is the off-road or cross-country version. Stream itself is actually an acronym, meaning subsurface tomographic radar for extra wide area mapping. Exactly what we need. As our sites and towns become more and more congested with infrastructure, and our demands for high-speed broadband along with improved utilities, our highway networks and the space below our feet is at an absolute premium. Having above ground and subsurface information allows planners, designers, engineers to design around any risks or issues and minimise project delays or costs incurred by having a cable strike on a site. Correct and detailed mapping ensures that design teams have the information they need to avoid this existing infrastructure. As you can see from the images, the infrastructure beneath our feet is a complex network of pipes, cables, and services. We need the equipment to be able to map this effectively, efficiently. The StreamUp is a multi-channel, multi-frequency, double polarized and lightweight GPR system dedicated to utility mapping on extensive areas. The system uses 600 and 200 meg antennas arranged in HH and VV double polarization. It allows fast and comprehensive GPR surveys to be undertaken effortlessly. Due to the system's lightweight nature, it's not in contact with the ground at all, meaning that speed and maneuverability whilst using the system isn't compromised. The system's almost completely traffic compliant, so it can be used in normal traffic conditions without the requirement for costly traffic management. Let's have a look at the StreamUp and the complete system workflow. The StreamUp, the whole system, weighs in at 95 kilograms, meaning that it can sit on the tow bar of any vehicle unassisted. The lightweight and compact nature of the system means it only requires 2 people to mount the system on a vehicle. It's ready to go in less than 15 minutes. The survey vehicle can then be driven at normal speeds to the survey area. Once at the survey location, the system can be dropped nearer to the ground and the highest quality data collected at up to approximately 40 miles an hour. The high scan rate and dynamic stacking improves the signal to noise ratio without having to modify the system settings. Linked to a Leica GNSS positioning system, the StreamUp has a smart algorithm to accurately calibrate the system's encoder, ensuring survey data alignment. Collecting data via the UMAP acquisition software is then straightforward. The surveyor can remotely control the system from the cab without any physical connection between the PC and the StreamUp. You can perform real-time diagnostics and fully control the system from this software. Whilst collecting data with the StreamUp, you don't require an escort vehicle or traffic management. This ensures freedom to carry out the survey as required. Not only is collecting the data fast, but also the download and post-processing element via IQ Maps is fast. IQ Maps uses immersed reality during the post-processing stage to increase the visualization speed, usability, and data analysis. It's fast. Okay, let's have a look at how easy the system is to assemble. It's made up of 4 modular units, the first being the SCU or Supply and Control Unit. This fixes to the tow bar of the car along with a confident lock connection. From this unit, we can then hang the centre antenna arrays. That includes the number plate boards and lighting, which ensure traffic regulations and requirements. Then, from this, we have the antenna arrays left and right, which complete the system. These are then covered with a lightweight shell for protection. We're then ready to drive off to our site at normal road speeds. System itself takes about 15 minutes to put together with 2 people. Okay, once we have arrived at our required survey area, we can just lower the system towards the ground, still not in contact with the ground at all, and start our survey. We can drive in normal traffic conditions, collecting high quality GPR array data at a higher acquisition speed with improved data quality. Collecting the GPR data is simple. UMAP is the acquisition software used by the StreamUp system. It has a straightforward wireless interface between the StreamUp and the PC. From the acquisition software, we can fully check and diagnose the GPR system and ensure all the antennas are running correctly, along with details regarding our positioning system. We can then start a survey with the simple play button. UMAP isn't phased by data size, meaning you can collect as much data as you need in one project. The data is displayed on screen with background mapping to show exactly what areas have been covered by the StreamUp. This ensures no areas are ever missed, or areas that are temporarily blocked earlier in the day can then be filled in later during the survey. The StreamUp system has dual frequency antennas along with dual polarization. This ensures that with one single pass or swathe, we're picking up shallow and deep pipes that are running in both directions. Let's look at how the system actually works on the road. Collecting our GPR data is really simple. We drive along our carriageway or survey area covering the site. The antenna itself is 1.7 meters wide, so each pass or swathe covers that particular width. Over a standard carriageway, we may need 3 or 4 passes to ensure full coverage. The areas covered as we're driving along can be seen easily in UMAP to ensure full coverage. When we've collected our data, we'll then run that into our post-processing software, IQ Maps. So IQ Maps is the post-processing software that we'll utilise for all the Stream family of radars. In this case, we're going to post-process some data from the Stream up. So let's run this data in and have a look at it. Simple case of importing the survey, which then is immediately displayed on the screen. We've got background mapping showing immediately, in this case a Google Earth image. We can check to make sure that we've got all of our survey information included. Where we have gaps, where there's been splitter islands or anything like that, we can see nice and clearly. We can also add other background mapping information. In this case, we've undertaken a topo and utility survey already of the area, so we can add that information in. We already have EML responses, so we can utilise that information to give us a greater quality level to our PAS 128 survey, for example. As you can see, that information is displayed clearly and easily. We can adjust any of the GPS trajectories, and also we can change any of our GPR processing filters. Or if we're happy with standard processing, we can go into our inspector tab, and this is where we can start drawing on buried pipes, cables, services, voids, those sorts of things. We can change color palettes simply. We can work down the tomography looking for linear responses, linear reflections from our GPR system. Here we can utilize either tomography or the B-scan to draw on our buried pipe, cable or service. As you can see, that's a real straightforward process to do. If we know the diameter of that particular utility, we can add it in. If we know what service that belongs to, then we can also change it from a generic GPR response into telecoms if we know it's a telecoms response. We can change the depth of a service if it drops in depth. And again, we can utilize both the tomography and the B-scan to give us that information. Again, changing the diameter if we know what it is. If we don't know what that feature is, we can just put it in a generic GPR response. Again, we can work through the tomography looking for more linear responses, or we can quickly and easily visualize that data in 3D. So this is the tomography working from ground level, working down. And those are the pipes that we've just drawn on. Obviously, we'd repeat this process across the whole of the site, utilizing other background information, any other information we have. And when we're happy we've completed that, we can export our data back out and import it then into AutoCAD or something similar. There's our data exported. That then, as a DAT file, can be imported into CAD via the IDS GCAD add-in. Okay, so let's have a look at the StreamUp system productivity analysis. If we were working on site for 4 hours at an average speed of 20 miles an hour, we're likely to cover as much as 144,000 square meters. If we were charging the client 50p a square metre, that cost would be £7,200. If we were charging £1.50 a square metre, that would be £21,600. And you can see, if we increase our working time, an 8-hour day, and our average speed, we're now working up at 40 miles an hour, say, we're then covering 576,000 square metres. And again, if we're charging the client 50p a square metre, we're then at £28,800. Or if we're charging £1.50 a square metre for this service, we could be charging £86,400. So you can see the productivity and the money that can be made from this system covering large areas very quickly can be extremely profitable. Okay, at the start of this session, we spoke about the potential to combine our technologies, sensor fusion. Here, we've had a look at the Pegasus 2 Ultimate and the StreamUp GPR. Let's have a look at combining those technologies together. Antonio and myself spent a little bit of time at our training school up in Whitchurch in Shropshire, looking at how the potential of these systems working together can benefit us in the survey community. Here we can see the StreamUp on the back of the vehicle with the Pegasus 2 Ultimate mounted on the roof, all ready to go and survey above and below ground. Okay, let's have a look at the data we collected up at our training school in Whitchurch in Shropshire with the StreamUp. Again, as with IQ Maps, we load the data in, it gives us an immediate image of where that data was collected. Then I can process the data, I can draw my pipes and cables on, and I can look at that and visualize that in 3D. I can switch off my swathe lines, look at it in 3D. I've got the road level there at 0. I can drop down through the ground, and where I've drawn my pipes and cables on, as we get deeper, they appear. We can see we've got manhole covers and chambers, various pipes and cables, all shown in 3D and geographically correct. We can see from simply dragging up from the bottom back up to the surface how those pipes then disappear. All we're missing now is the data above ground to create that full 3D model, that digital twin that we're after. So now let's have a look at all that data combined.
In previous slides, I was able to explain how the Pegasus 2 acquisition is being done. So we start with 5 minutes of static, 10 the dynamic, and we are ready to capture. Shane did a similar task, and he was able to explain how the StreamUp acquisition is being done. Now it's the time where we need to talk about a combined acquisition for the Pegasus 2 and the StreamUp. First, let me say that we need to start with the same 5 minutes of static and dynamic to make sure that initialization is being done. But then we can just and in a unique visit to site to collect all data below and above the ground, with the advantage that the post-process trajectory from the Pegasus can be utilized as well for the ground penetration radar software and that will be used to extract all this information. All data is being processed, and now is the moment where I will be presenting the results of the Pegasus tool. You can see now the point cloud. I will be playing with different LiDAR attributes. So in this particular case, I'm just present the classification, automatic classification. So the software is able to classify the data in 7 or 8 different layers. Now I'm just remove all 3 layers of vegetation: low, medium, high vegetation, hardscape. All buildings are classified, and in this video I got the color in red. So let's remove all buildings as well. And at the end, I'm just removing a parked vehicle that was classified as unlabeled. Saying that, if you just need to export the layers that are now in the image, that is just road and pavement, I will be able in my software to just go to export menu and export the road and the terrain as LAS for a final.
Okay, so this is our final slide showing the data from the Pegasus 2 Ultimate and StreamUp working together, creating a digital twin of a real-world environment. We're working towards powering an autonomous future. So that brings us to the end of this session. If you'd like any further information, our contact details are on the screen. Thanks very much for listening.